good luck. Let's start. So thanks everyone for joining again. So this is our first protocol forum #1 starting from 2022. The idea of the protocol forum is to include everyone that has been or will like to get involved in the Superfluid Protocol going forward. Superfluid Protocol currently don't have a DAO yet, but going forward, the idea is to make it a more decentralized, more community involvement. So having more community involvement in the direction of how Superfluid Protocol is built or upgraded it's basic. It's what the protocol wants to be in the long run. So Superfluid Protocol is meant to be a token standard, and we don't have an EIP yet. And so I think as a starting point, this forum is a way for us to come to figure out what would be the ideal EIP for a super token standard is, and as a way for us to figure out. So that thanks everyone for joining again. And as a starter, this week we're going to talk about the solvency buffer feature, and that is very critical in making sure that the super token is solvent. I guess everyone here is already familiar with it, right? So let me just start to share the screen. Solvency buffer is our new term. I mean, soon our user dashboard is going to also be upgraded to the new terms, and used to be called a deposit. Just in case you were surprised here with the term. There are reasons why we changed to buffer. I'm not going to go through that. Mainly legal reason. Let's just put it simply. And there are two basic features. One is a liquidation period, which affects how much of the buffer is taken for each stream when you create. The other feature we are releasing is a minimum buffer. Minimum buffer meaning that if you create a very infinitesimal small streams, it will take a buffer not less than a certain amount, and it's configurable per token. And the idea is that on mainnet, one of the things on Ethereum mainnet, the reason we don't release is that the liquidation cost is pretty high, and if we don't have some sort of minimum buffer, and it creates a scenario that the Sentinel wouldn't have an incentive to actually liquidate anything because of gas costs. So one of the things we are adding is the minimum buffer, in short. The third thing is we're adding is called 3Ps. I don't know if Tony, are you part of the Sentinel network yet? Are you running anything?
I'm not running a Sentinel. No, I haven't. I've had a look into it, and it's something definitely we're going to be doing. I just wanted to ask a question about. Actually, yeah, would you like me to ask questions now, or would you like me to hold any questions?
Let's freeform. I didn't prepare too much today. Hopefully, in 2 weeks we'll have a better preparation. But today we're just. Feel free to interrupt.
Okay, sure. A quick question about the minimal buffer. So what is so this will be some constant. So what is the formula for calculating this minimal buffer? Sort of what's the thinking around that?
Yeah, so if we write a bit more details before we go to 3P, is that it's a governance configuration. So it's configurable per token. Default is, well, trivial case, default is 0, like the case now, right? So for example, on Polygon, if we say for DAI X, super DAI, the minimum buffer would be $1, then we can configure using the governance, which is a multi-sig. Eventually we'll have more controls by community and partners or different kind of interest group. So we can configure for them to $1. Then or every stream would have at least one minimum $1 as a minimum buffer for DAI alone, right? It's arbitrary number. In practice, it will be much lower number, but that's just to cover the Sentinel, the minimum cost. Let's say.
Yes. Is it maybe me, but this number feels like you want to be able to update this number quite a bit, sort of frequently. I mean, depending on network activity, depending on tokens, or is this a number which, I mean, so it's $1 for DAI, but if you take a kind of a volatile asset, I don't know, EFX, and then depending on network activity, of course, this sort of minimal buffer kind of has to adjust with that. Or do we not think so?
So that's a good question, because currently we will have a fairly simplified model, which is governance configuration per super token and adjust when needed. And so it won't be super frequent, because governance configuration is kind of expensive process, right? So several people need to send a signature, and it's very hectic. So we prefer not to. So obviously that leads to problems, so it's not as dynamic it could be. So in the future we could discuss about how the minimum buffer is dynamically adjusted, or according to whatever formula it is. If you have some thoughts about it, it would be good to someday discuss it. But
yeah. I mean, maybe there's one kind of initial thing. Let's say you want to say the minimum buffer is $1 per stream. It's $1 in dollar amount, but then you have these. You kind of need to know the conversion price of these tokens. So you need to use some sort of oracle to figure out what's the actual dollar amount of ETH, and then you can kind of take the buffer appropriately.
We could, but currently configuration doesn't have an intermediary lookup or something, right? So unfortunately it's not at the moment. Okay. But going forward, if it's a problem, we'll adjust, especially on layer 2. We're going to layer 2, right? So it could be a bigger problem than Polygon. Polygon seems just grow. Well, the cost is going higher, but it's still not something out of control yet.
Just briefly on this topic. So, I mean, if really the only reason that we have these deposits is a sort of incentive / gas compensation mechanism for the Sentinels, right? So I don't think this idea would really play well with the toga that we have in place. But I think, what would you think about if all deposits were basically in like native Matic or the native token for that chain, right? Because that's what, like as a user, I'm going to have that on hand anyway because I have to pay gas fees. And by using this, like we can ensure, basically just by roughly what the average gas cost is at the time, we can compensate for that, right? Like it might not be as profitable for a Sentinel, but it's something that would be a little more consistent in terms of paying for gas.
Right. So some sort of a gas tank, right?
Right.
So you pay the buffer not in that native not in that particular super token, but a consistent reward for the token, for the Sentinel.
Right. Yeah, because I mean, at the end of the day, right? If I'm just compensating for fees, I'm going to swap it, on a DEX anyway, back to Matic.
Yeah. It was part of the discussion before in this topic generally. There are a couple of reasons that from UX point of view, so if you would have to have the gas token in order to use that create a stream, that create extra UX problem. So currently the UX is that you have to have the gas token in the first place, right? That at least we can expect that. Then obviously you need to have the token itself, the stream token itself. And the way you suggested is that, are you suggesting to have just the gas token itself, not the super version of it, but just the, let's say on Polygon would be Matic instead of Matic X?
Right. Yeah. So if I'm on Polygon and I want to stream USDCX, like I have to have Matic on hand to pay for gas costs anyway. And if the compensation is really just to cover the Sentinel gas, then I just basically pay the gas and then put a little bit of Matic up. Actually, I guess that could probably be done in the same transaction with the contracts, but yeah,
so
that's the idea.
Yeah, that's called a payable version of the create stream. And you're familiar with payable function, are you? I guess.
Yes.
Yeah, so you have to kind of attach certain amount of gas token when you create a stream. So that does create several problems. We thought about it for sure before. Didi, if you want to add, let me just.
I wanted to add,
Mhm.
as you say, we thought about it, and one problem is that if we make that payable, then this propagates to every other function using that would also need to be payable. That would be pretty bad. However, I think what we didn't consider is that there could be a version which is payable, and we could still have a version which is not payable. So if somebody already filled up a gas tank, they could use the non-payable version. So that could maybe mitigate that problem.
No, I think we thought about a gas tank. It's just we try to avoid a gas tank because UX is complicated.
But did we consider a gas tank which uses the native token and which is optional? So where you could choose, you could either upfront fill up the gas tank if you expect more transaction, or you could do it in one transaction using the payable. Did we consider this scenario where we have both as alternatives?
I don't think we go that deeper into that many alternative. I guess, yeah, we can. No, we haven't. Not sure for UX wise. I mean, in the end, the concern is about the user experience. So if people come to our website, they have to fill the gas tank. If they don't fill, there's alternative behavior. How do we solve that? It's more than just protocol level, right? I guess, but the simple answer would be no. We haven't think through all the alternatives. If anyone wants to entertain this and think through from UX to in the end, how does it work? Like end to end in all cases. Happy to include that in the future chat. One thing I want to mention about the payable function is that there's one problem with payable is the moment you introduce payable, and then you should include something called estimate fees, right? So because when you do payable, the question is how much you attach to the value when you call the function. If you don't attach enough, the transaction may fail. So you have two strategies. Either you do an estimation upfront, which means we have to provide a estimation function, if you follow me, or you attach a large enough value that you know that it will cover the upper bound amount, so you would never revert that transaction, right? So the payable has its own drawback, also from UX perspective, in my opinion. And we don't currently have something called an estimation yet, because the protocol simply take the deposit away without asking. Not sure if it's ideal, but payable is more explicit, basically saying that, okay, this is amount of the buffer we give, where we take it away for the Sentinel later as incentive, and we can get it back later. Yeah.
I think in the short term, the token specific minimum deposit is the best way forward. And I think the gas token in the future could be an alternative, especially for tokens where the value is volatile and where you may be able to achieve a lower threshold if you play with the gas token. Maybe that's something which probably could play out.
Yeah, I just wanted to echo something on the UX side. So I think I echo support to what Miao said. I think using this gas token approach, especially for protocols who rely on Superfluid, this sort of the UX effects ripple through the entire ecosystem. It's sort of like and if Superfluid thinks it's complicated, a very well-funded company with many developers, this sort of just makes it more complicated for smaller projects and even just single developers and so forth. So yeah.
Yeah, and the payable function also has ripple effect. If we don't have the estimate buffer, fine, we just or using a upper bound buffer, just in case, right? When you have an app involved, I think Tony, your diagonal is also a super app, right? And then the estimate buffer function is pretty hard to do actually. You kind of need to simulate the chain of events and estimate how much buffer the app would use and you would use. So it's kind of an overhaul of the protocol. It's something we can think about probably in the next version, but it's pretty hard to do when it involves the super app, I guess. That's the complications. But upper bound could be always, could be part of the governance even or pre-configuration. So you always set up upper bound, so it the chain of Superfluid protocol will just take as much as a need from the pre-allocated buffer, if that makes sense. Gas tank is even more complicated. Yeah, I mean, I don't know if you guys used what is called monolith, the payment card. So the previous version they had was with the gas tank. They eventually scrapped it because in order to use a card, it's a Visa card, and in order to use card, you have to fund your gas tank, and so you have always two steps: fund your gas tank, then top up or other transfer function or something. So it's a smart wallet with a gas tank. So I would think that a gas tank can be a little bit UX heavy, probably. Did you have something to add?
Oh, no.
Right.
No, I just want to say that's also where I know it from. This gas tank concept.
Yeah. Shall we move on? Yeah, cool. Okay, so minimum buffer is guess better to write the original. So in order to cover minimum gas cost for Sentinel. Dynamic configuration is not yet in current implementation. Some sort of, yeah, it's pretty hard to say which type. So that's the minimum buffer, and there's a 3 Ps. It's another feature that create different incentives for with different period. That will be patrician, pleb, and pirate. Perhaps here we should go back a little bit about what does this 4 hours mean. Some of the technical detail we could go. Actually, we have discovered some of the nuances here even lately. Currently, when we say 4 hours for the solvency buffer, is that when you create a stream, it will calculate for 4 hours how much it would stream, and that is used as a buffer. But if one account has multiple streams, even the account goes to negative, it might take more than 4 hours to drain the buffer, if that makes sense. Right, but not less than 4 hours, I think. So, for example, if the account has a stream of 1 per hour, the buffer is 4, right? That's outgoing. But when the account receive incoming of 0.5 per hour, then the net flow rate for the account is minus 0.5. Does that make sense? So the 4 hours buffer would take actually 8 hours to drain. So that's a intuition that needs to be clear here. So for any account, it can take more than 4 hours to drain all the deposit. Due to you might have incoming streams. So the idea of 3 Ps, so different period, is that we want to incentivize toga pig, which is we call it patrician. So we want to incentivize them to do the liquidation job as fast as possible. But what doesn't have at the moment in the system is something called a plab, is that currently only when the account run out of deposit, then you enter something called pirate mode. So pirate would create a liquidation and the toga pig would be punished, right? So they will have to pay the penalty, and then the pirate get the penalty amount, and then the toga gets a penalty, and the toga pays for the penalty in a sense. So we only have 2 at the moment. So what we're adding is something called a plab. So that intuitively, let's say in a simple case, one account only have 1 outgoing stream. Let's not make it complicated for now. So let's say the outgoing stream is 1 per hour. It takes 4 hours to drain its $4 deposit. And after 4 hours, it enters pirate period. So all the deposit runs out, and the toga would pay a penalty. Current penalty is counted as the amount of deposit it drains out. So it's an arbitrary penalty amount per stream deposit amount. And before the deposit runs out, it's always toga to get to the rest of the deposit. What we want to add is that we want to incentivize toga pig to finish the job as soon as possible. Let's say 15 minutes or 1 hour. Well, let's say 15 minutes. And if toga finishes within 15 minutes, the reward is his. But if it finishes after 15 minutes, so between 15 minutes and 4 hours, it's a plabs that takes the deposit. So we allows more sentinel to have incentive to be in the system, because they could be the one that take the rewards when the toga is slow. Then it should be. So that's the idea of 3 Ps. Is everyone following?
Yep. And just to make sure, the period in which only the pick has access to the reward, that's just 15 minutes, right?
Under the rules of 3 Ps, yes.
Okay.
Yes. 15 minutes is current thinking, right? So it could be other numbers. So let's just, for the sake of discussion, let's say it's 15 minutes. You have to finish all the liquidations, yeah.
Can I just make sure I fully understand that? It's so when an account goes negative and they can be liquidated, the patrician has some X amount of time to perform that liquidation, and if they don't, then the pirates can liquidate them and punish them.
Yes, pirates by definition is when the deposit of the account even runs out. So basically become insolvent account.
When it comes to insolvent account.
Yeah. So the pirates takes everything.
So the pirate takes everything, but this sort of time buffer. So when the account becomes insolvent and basically ready to get liquidated, there's some sort of time buffer where the patrician only has the right, or how?
Yeah, when there's still deposit, there's
when there's still deposit. All right, yeah, there's 3 stages. There's like negative, insolvent.
Yeah, so negative is split into 2 periods. One is when there's deposit, when there's no deposit. And we are further splitting the when there's deposit into 2 periods, the patrician and the plab, so that the plab can get additional amount of deposit when the patrician, which is toga pig, right? Or let me write it down.
That
I like
makes
to
sense.
sell as a pig, but just I like. So patrician toga pig is just like 15 minutes. So you really need to do the job fast, let's say. Right, so that's to incentivize faster liquidation, and pleb kind of have a chance to have also some of the leftover rewards from the toga if they are slow. Currently, there's no such incentive. Currently, we wait for the pirate, and there are a lot of feedback saying that okay, I run a sentinel, but there are 4 hours most of the time. The toga pig always finish the job, right? So it's pretty low incentive. So we're trying to add the additional kind of gaming aspect so that the toga needs to do the job faster. So that's the thoughts.
Gotcha. Thank you.
Although there are some complications because I specifically made a simple case. So when the account only has one outgoing stream, right? So simple case is one outgoing stream account. Let's say 1 per hour. Right, this is simple case. So that means 4 hours. Sorry, 15 minutes. 0 to 15 minutes. That's the patrician. 15 minutes to 4 hours. That's the pleb, and afterwards it's the pirate. Right. Okay, so they are more like a complicated case. More complex case is that you have multiple streams, right? So then the calculation becomes slightly more complicated because firstly, your net flow could be even 0, right? But when your net flow is 0, usually your account shouldn't be negative, but let's say, but let's make it as simple. So let's say well, net flow is negative. Let me give it. One per hour outgoing. So in this case, your net flow is minus 0.5 per hour, right? So in this case, what we want to achieve is that it should be still the same. Didier, am I following here? Correct? In this particular case, can you remind me? So it's 1 per hour outgoing, 0.5 per hour incoming. So net flow is 0.5 per hour. And what we want to achieve is that okay, now there's a deposit or buffer is 4. In the first case, flow is 1 per hour, buffer is 4. Yeah, bear with us. It's a number crunching here. So the buffer is 4 because we have one outgoing stream, and what we want to achieve is that between 0 to 15 minutes after the account becomes inactive, if that gets liquidated, it should be patrician gets a reward of between 15 minutes to 4 hours. It should be the pleb. The rest is private, right? Does it make sense? It's still a fairly simple case, right? Okay. Another thing is multiple streams. Case 2. This become more complicated. There are some limitation that current implementation we unfortunately made it is that let's say we have 1 per hour outgoing plus another 1 per hour outgoing. So we have 2 outgoing at 1 per hour. Then we have another one which is 1 per hour incoming. So the net flow is actually 0.1 per hour, and buffer is 4. Buffer is 8. Right. So we still want to achieve that when the account is negative between 0.0 to 15 minutes. So it means, okay, let me make it clear. After the account becoming negative, that's a precondition. After the account become negative, in this case too. And what happens? So that's the question, right? Ideally, we should know that the total outgoing stream, total outflow rate should be 2, but currently in the protocol, we don't have that information. Why? Let's look at the protocol code. You guys, I hope I'm not losing you guys. So if you have any clarification, let's slow down here. Let's get this right.
No, it's good. It's good.
It's good. Okay. So if we look at the constant flow agreement, we have one limitation, which is unfortunately introduced when we're trying to optimize gas for the mainnet, right? So if you look at how the data packing is down, I mean, Joshua, you did some early work last year, I remember well, right? So if you still remember this horrendous data format, what you could notice that we have a timestamp, it's 32 bits flow rate, and we have a deposit and order deposit, which is clipped 32 bits, right? So in fact, the deposit is 96 bits, as the same as a flow rate, but the lowest 32 bits is clipped off, so the information is lost in order to jam everything into one word, which is 256 bits in protocol. We won the game of saving one word, but we lost a lot of information. Actually, in this case, the most critical information is this flow rate is no longer having the information about what's the outflow, total outflow rate, and total incoming flow rate, right? So because it's netted out, become net flow rate essentially. So the information is lost. And the initial design, actually, before we come to this version, we had actually them separately stored, but there was no way to jam everything into 256 if you want to have the property of 18 decimals as a default decimal the total super token should have, right? So 18 decimals waste a lot of bits, right? That's first culprit. We kind of, so we forced all the super token to be 18 decimals, and that'll waste a lot of bits. So there's no way to jam everything to one word. And the second thing is if we want to store both flow rate, total outgoing and total incoming, then there's no way, right? So information is lost. You have questions? So because information is lost, right? So let's make it clear. So total outgoing is 2 per hour, and total incoming is 1 per hour, right? So this information is actually lost, and I can just strike it off, right? So in an ideal way, we should be able to calculate 8 divided by 2. That would be basically saying that if all the incoming flow disappear magically or unexpectedly at any moment, then you have to sustain the outgoing flow rate, right? So total outgoing flow rate. That's the concept of buffer. So we prepare for the worst case, which is your incoming flow all disappeared, right? And you should have 4 hours of buffer. But because the current information is lost and we're only left with a net flow rate, which is 1, so that means the buffer become 8 hours. Then it's pretty hard to recalculate, okay, who is a patrician, who is a pleb, who is a pirate. So what we did, maybe Didi, you want to jump in now? What we did here is trying to recalculate how much is the, re-estimate how much is the total outgoing flow rate based on the current liquidation period, right?
Yeah, currently. So the consideration is at the moment the deposit is proportional to the outgoing flow rate. So what we can do is we can indirectly derive the outgoing flow rate from the total deposit of this agreement. And that way, yeah, we come to this number. There's edge cases, however, like the liquidation period could change, and that would basically break this calculation. So it's not yet 100% clear how we can best handle that, but for the case where the liquidation period remains as it is, this seems to, yeah, to be a good workaround, or let's say to achieve the same goal of knowing what the worst case scenario is, and based on that correctly determine the period. So just as a reminder, it's only, but it's just about correctly detecting in which period we are in terms of 3P. It's not about liquidation itself failing or something. It's just about correctly allocating, okay, who should get the rewards for this liquidation.
I think I actually made some mistakes, sorry. Let's make it clear. So because the buffer is 4, because the net flow is -1, so it takes 4 hours to drain the deposit, right? That's a simple case. Actually, in this case, because the net flow is 0.5, it takes 8 hours to drain the deposit. So that means between 15 minutes to 8 hours should be pleb, and afterwards is pirate. Am I right? What we want to achieve is that the patrician period should be fixed to 0 to 15 minutes, while the rest until the deposit being drained should be pirate. Incidentally, I just want to mention that we're actually trying to dump all the test outputs and trying to create a more visualized presentation of the things we talk about here. So that's something we can present at some point, but at the moment the tooling is not there yet. So we're just trying to reason about it in an abstract number here. Do you think that's what we have now at the moment, between 15 to 8 hours?
No, what we have now is basically what we would have if we had the outgoing flow rate still stored. That's what we have now. As
Okay,
long
so that
as
means
as long as the liquidation period is not changed with streams open, because then we got a mix of streams which have the deposit according to the old liquidation period and streams which have deposits according to the new liquidation period, and then this indirect calculation stops being correct in our cases.
But do you see the dilemma here that we should put 4 or 8, right? So because there's still deposit which is in the deposit still the buffer is still not burned through yet until 8 hours. And so it takes 8 hours. I mean 8 hours.
However. So I think 15 minutes is also not correct. I think everything needs to be scaled up in this scenario. So I think the 15 minutes also become 30. It's my opinion, it's proportional. It's maybe minutes is not the right measure. Maybe it should be interpreted as proportion of the time period.
Yeah.
Of the net flow rate rather, right?
No, I mean proportion of the critical time frame, because if we do not ignore the incoming streams, then it could be everything between the 4 hours and infinite. It could extend to anything.
So the idea is like, instead of it being 15 minutes, it's more like, I guess 1/16, right? Like it's basically just like a percentage, right? Like a percentage of the buffer has been drained by that point. So it's just not hard coded to 15 minutes, you mean?
Yes, I think that's a better interpretation. And
okay,
that's basically equivalent to ignoring the incoming streams and just doing the worst case scenario.
I think that makes sense. I wonder how hard it would be to implement that, like on the Sentinel side. You know, because I mean, I guess it wouldn't be too terribly difficult, but it'd be a rework, right? Because like right now, I can hard code like in the ENV, you know, exactly how long I want to wait before running liquidations if I'm not the pick, right? So if this is the case, then I think there would need to be a little bit more configuration on it.
Well, but I don't think that changes anything on the Sentinel side.
Well, like the idea is like, so right now, if I'm not the pick for a token, then I want to set my delay to 15 minutes, right? So I can, you know, get this half reward or this partial reward. But if like in this case, you know, basically it takes 8 hours to drain the deposit, then instead of 15 minutes, it would be 30 minutes before I would actually get any portion of the reward. So by hard coding the 15 minutes, like I'm making liquidations for the pick, but I'm not getting rewarded for it.
Actually, yeah, right. You're right. I didn't think about this.
Yeah, but to know the number, is it 15 minutes, is actually not so straightforward. So I'll give you a case, number 3, which I haven't. So it's specifically like you start with a 1 outgoing flow rate, a 1 outgoing stream, and your account goes to negative. Then there's a during that phase that you are negative balance, and there's incoming stream. So it cancels out your outgoing, so it becomes net flow rate 0.
Yeah.
1 per hour incoming, and net flow is okay, account balance negative. So I described this scenario already after the fact, but in order to have that happen in the first place, what it should happen is that you have an outgoing, and while your account is inactive, so no one liquidates you yet, then you receive incoming, right? So your balance would become like your net flow will become 0, and buffer is 4, and in this case, it takes forever in this case, right? Because your buffer would never, buffer is less than 4, slightly less than 4. So slightly less than 4, let's say, We don't know how much, but anyways, because it's net flow is 0, so it takes forever to drain the deposit. Then how to get this number of 15 minutes? That was the initial conundrum we had, and that's why we tried to figure out the alternative rules set for this case. Right, so I'm leaving these two cases kind of question mark now, like what are the rules to apply?
Actually, there is even additional cases, and yeah, thanks, Joshua, for pointing that out. We didn't yet consider that. Yeah, of course, in the Sentinel, this also needs to be considered. So two things I want to add. So one is because initially we tried to calculate the period by looking at the net flow rate in the protocol. And why I didn't like that is because the net flow rate can be influenced by anybody. So I could just sandwich that transaction where I first sent a stream to you, which makes your net flow rate 0 or positive any number, and that way I can just shift where in this window it is. And the other observation is even if there is no incoming stream involved, the same effect you could have by sending lump sum, so one-off transactions. That way you could also switch around where you are. So I really think the best way forward is to stop thinking about it in terms of time and think about it in terms of percent or share of the buffer. So if you say that the buffer is 100%, whatever the liquidation period is, which defines it, the patrician period is a share of the buffer. So for example, the 15 minutes, I think, would be 1/6 or so, or 1/16, I think.
Right. And so I think the only thing we would need to consider is if the net flow rate ended up at 0, right? Because then percentages of that would be 0, right? So
no, but it's not the net flow rate is not relevant there. It's percentage of the buffer left. So if the net flow rate is 0, it just stays where it is. It doesn't change. So if it's in the patrician period, it will remain in the patrician period indefinitely as long as the net flow rate is 0. If it's somewhere else, it remains there.
Percentage of the buffer left, meaning rather the percentage of the negative balance over the buffer, right? That's easily calculatable. So
yeah,
you know the
but
balance.
that is the formula in place actually in the protocol, but not in the Sentinel. We didn't consider it in the Sentinel.
Okay, so let's say when we have 8 hours to drain the deposit in this case,
yeah,
and what are the percentage we're talking about here is for the patrician?
So I think here it would still be at 100% of the buffer. I think it just started eating into the buffer, right? In this scenario.
Mm-hmm. But it takes 8 hours to drain, right? So if we say the rule for patrician is not necessarily by the minutes, but just by the percentage. So the patrician actually has longer than, in this case, we're talking about 30 minutes, right? Perhaps.
Yeah, right. It would just scale with whatever the current projection is.
We could, but is that what we want? I mean, that's the next level of question.
I think it is, yeah.
How so?
I don't know. To me, it intuitively feels right. To me, it feels like this definition we did in terms of minute somehow implicitly assumed this simple case of, okay, there is just this stream, or there is no incoming stream, or they are ignored. To me, that was somehow even always maybe too implicitly clear what would be. I think we didn't make it explicit enough, but yeah, I always understood it like this.
Okay,
because
so
the other cases are simply can't handle if you define it otherwise.
Okay, so that means we have two ways of looking at it. One is 0 to how much 1/16 deposit left.
Yeah.
Yes. 1/16 to 1 buffer. always use deposit. I'm still not changing my words yet.
Wait, patrician? No, patrician would be, so everything 16/16 to 15/16. It would be the initial part of buffer left, I think.
Excuse me?
Because the patrician spirit is at the start of eating into the buffer, not at the end.
Yeah, so it's 0 until 1/16 of buffer used. That's what I meant.
Ah, used, okay, yeah.
Yeah.
Put used, it's sort of left.
Yeah, excuse my inaccuracy here. I'm just trying to type something quick. Sorry. My computer is going crazy. One moment.
That is the wrong operating system.
How to use Mac.
You're back? Your internet's back?
Oh yeah, our internet was out like 20 minutes. Left.
Right, okay, so for the case, multi-stream case 1, that will be 0, same thing, right? 1 until 1/16 buffer used. But in this case, it would be 0 to 30 minutes after the account become negative, right?
Yeah, if the net flow rate remains the same and no incoming transfers take place.
Yeah. That's true.
Maybe it's, I think of it like Didi said, I think of it in terms of percentage. So like in the 15 minutes is basically 6.25%. You have 6.25% of the buffer, which patrician has the rights to. And then once we get past this 6.25%, then everyone else can, well, then the pleb can have the right to it.
Yeah.
So we basically need to rethink how we name the stuff, because for example, in the sentinels, there's this offset in terms of seconds, which is defined. So yeah, we need to do that differently.
Sorry if I just made your life harder, Axe.
No, I'm actually happy that you pointed that out. That's important.
Right. Well, I mean, if we're going with this model, then we'll definitely need some sort of adjustment. I mean, with that, I think it'd be less configurable, but like, why would you want to configure it any different than trying to be the first one, right, in the pleb period to get the liquidation, I guess.
And the case of number 3 is even more funnier, is that when that happens, you are kind of stuck with the period. It's not moving anywhere, right? So we're stuck with a percentage of deposit left.
Which is okay, however, I would say. Because for a protocol, if you are in the patrician period and but the patrician for some reason doesn't liquidate you, but it's still okay because it doesn't get more critical than that if it's evening out the account.
The account is stuck in patrician lab or pirate. Right. Okay.
Yeah.
I guess if I re-ask the question, re-emphasize the question again, so is that what we want? Because initially what we want is to incentivize the Toga peg to liquidate as soon as possible, but there are cases that it will be forever patrician because net flow rate is low, so that they could liquidate they could simply not liquidate until necessary, right? If we take the multiple stream case 3, in extreme cases that we have a net flow which is really small and it's negative for the account, but it's also in the patrician period. But since net flow rate is really small, so it takes almost forever to drain the buffer, right? So
I guess you could construct a case where the partition period takes years, basically. If you say 1 byte per second, I guess that's enough for years in the partition period.
is that anything? Is that problematic for the protocol? Perhaps not.
No, I don't think so.
Just to brainstorm a little bit more, do we have actually the information? What actually is interesting here is after the account become negative. I guess the whole reason is that we don't have this number directly, right? Otherwise, we could use that as a rule. So what does after account? Yeah.
So I think it wouldn't even be possible in the protocol to always know for sure how long it had been negative. In my opinion, we don't have the information there to even know that for sure in the context of liquidation transaction.
Yeah, let me just take notes that
because an off-chain observer could tell, but I think
no, but as an on-chain rule, it should be available on-chain, right? It can't be just off-chain.
Yeah.
If we make that as rule, it should be.
Yeah, and I think that on-chain it's not possible with the data we have.
With the data we have, no. Maybe, well, maybe with in the interest of developing the EIP or next version, we could take this into account, right? So the information is not on-chain, but might be very useful to make the calculation even more straightforward, I guess. Is that fair to say?
Yeah, so I think bringing back the distinction between aggregate outgoing and incoming flow rate would be useful going forward. So yeah, I think we should consider that.
All right.
Just
Yeah,
making
go
sure I
ahead.
understand. So if an account goes negative and the net flow rate is now set to 0, then it just stays as patrician forever, right? So it doesn't, like, we're not rewarding plebs or pirates for a liquidation on that, right?
Yeah, if it happens to be stuck there, yeah.
Okay.
Could also be stuck in the plebs period.
Right. Well, yeah, just yeah, because basically at any moment the stream that sets the net flow rate to 0 could close, right? And then it would eventually be available to everybody else. Because I don't imagine a stream would go on infinitely.
Right.
Okay. For anyone interested in examining that implementation more, our pull request is currently ongoing with that. That's kind of our logic, right? The percentage of deposit.
Yes.
Yes. Okay. That should be in the 3 Ps. And Vincent is the one that behind the code at the moment. So feel free to go and comment out the thing you think should be revisited, and yeah, feel free to contribute. Do you guys have any more for the external contributors? I mean, Tony and Joshua, do you have any more specific question you want to discuss here? I don't think today we can cover the zero balance super app feature of the CFA in general. So today's discussion is just about the solvency buffer.
Could we talk a little bit about the access control feature? So this is something Fran has briefly mentioned to me.
Right. Do we have time for that?
Just a quick overview. It doesn't have to be a discussion. Just yeah.
Yeah. So the idea is that how how many versions we have? Actually, I better if I have a previous notes, I might missing things here. The version that I remember here, did you remind me if I miss anything, is that you can allow a external contract to manage your flow. So be extension to the upgrade and extension to the current CFA. So additionally, you allow other contracts to manage your contract or your EOA even. We probably wouldn't limit that to manage your flow. This additional access control, I guess.
Oh, I see. All right, this makes a lot of sense now. All right, because all right, so there's one use case which we particularly useful for what we're doing. Diagonal is we want to be able to open a stream from an account given permission. So yeah, I mean, there are those use cases for this, but this is something which we think will be particularly useful. Yeah.
Yeah, exactly. That's one of the major use cases.
Yeah.
For example, if it's one of the use cases we thought about is close-ended streams. Like if you say I want to send stream for 2 hours, for some reason it's a very frequently asked feature about. Since we don't have access control, we can't allow a external external agent to close your stream, right? So unless you run out of stream, but run out of deposit, but it's undesirable because you lose the deposit. So we'd rather some external contract, whatever model it uses to control your close condition. Yeah, Didi?
Yeah, I have a question here to protocol users. So my understanding of this delegation features is there's a spectrum of how to approach it, and let's take 2 extremes. So for me, one extreme is in ERC20, you have a proof which has one parameter and that's it. So you can specifically give somebody permission to make a transfer, and you can set a limit for how much cumulative they can transfer. And on the other end of the spectrum, I see the ERC777 operator model, where you can just say, okay, I give some account access, but in this first step, they basically can do everything you can do. However, in order to put constraints, I can then additionally set hooks, which can implement arbitrary constraints for what these operators could do. And I'm wondering, do you have a preference? What you think would be most convenient as a protocol user?
Yeah, so I guess I think it's a different level of sophistication. So I can speak from us. So what we're doing at Diagonal, I mean, we want to enable basically subscriptions. So doing things like opening a stream from one account to another is important, let's say during free trials. Furthermore, being able to having the ERC777 model where we can act as operators will be quite powerful, because then you could even do non-streaming sort of recurring payments. But yeah, you know, I mean, so maybe it's just my preference, but I prefer more customizability on this. But the ERC20 proof, what's nice about it is it's so simple. So, and then the question really becomes though, who are the users of this going to be? Is it going to be, are people really going to be delegating these rights to many people? I'm not exactly they won't be delegating nothing to other people. They'd be delegating to other protocols. Let's say, well, we're building or what someone else is building and so forth. And then what's also interesting is what happens when a user starts delegating rights to Diagonal, to Triagonal, to some other one, and everyone has rights. And sort of this is kind of like where, especially when you have many operators in ERC777, this like becomes a bit messy, possibly.
Right. So actually, I would say that ERC20 is not as simple as it could be, because ERC777 actually made it even more simple, or even simpler, right? So it's just the operator. it has all the rights, but
Yeah,
ERC20
if I may, that's true. Yeah. So in that regard, 777 is even simpler because it's really the simplest thing you can have. You just say delegate to this account. It doesn't get simpler than that. Maybe the main advantage of the ERC20 model is that if you have a simple, or could also be a few simple constraint parameters, then that makes it much more likely that tooling supports it. To give an example, if if there's an approval request, then MetaMask will show me and give me an edit field in order to set that number. And that's probably the disadvantage of having just the generic and customizable model, that for that, if there isn't the most important standard parameters, if that isn't standardized, then you cannot expect MetaMask to show to users what they're actually signing there. So maybe there is also a bit of this kind of UX-related security aspect there.
Yeah. No, I mean, you're actually right about ERC777. Perhaps it was just availability bias, because I mean, from a user, most people don't really interact with these ERC777 operators very much in just regular protocols. But
I don't know of any sorry to interrupt. I don't know of any ERC777 token apart from super token in my experience. Do you know anything?
Yeah, I mean, at least nothing serious. There's maybe fun little examples out there.
I don't really know. What we could do, I once looked up, but I think that was ERC1820 use on mainnet. I mean, we could just look up ERC777 events and from that figure out what the most relevant 777 tokens are on mainnet and see if there's how they're used. I don't really know. Maybe we should do some research there.
That's funny. Even our token, I don't know if anyone has this. I can do you guys continue. Let me do a background digging.
I liked what Didi said about the granular approval. So maybe this is why ERC20 approval arguably works kind of well, is that, I mean, you just approve for a certain amount of balance. So like, you know how much you're approving. With these sort of ERC777, full delegation power, you delegate everything. And this is a lot. Like,
right, but but as I said, it's not that it's just binary, because okay, if you trust the contract, so if you're delegating to a contract, because that's also not a given, you could delegate to an EOS, as far as I remember. If you delegate to a contract, you could say, okay, that contract that is vetted, so I don't need to put further restrictions, it's trustworthy. But you could also say, I don't trust the contract, and I can additionally put my own constraints, could again be delegated to a contract via these hooks. And so it's in one side it's binary, but on the other side you can have arbitrary constraints with these hooks. This combination is pretty cool.
It is pretty cool. And I mean, actually, what's interesting? When you think about all these DeFi projects, they do infinite approval anyway. So they're basically, they want to give you all the access. Well, Superfluid doesn't.
I think not all of them, but I think most of them, yeah.
A lot of them do. Even the big ones, Uniswap does, and this infinite approval, I really don't like. And that's where the ERC777 delegate power, I guess, becomes more powerful. Well, I mean, that's where it's supposed to be doing, but yeah.
I mean, by the way, the infinite approval is also a kind of trade-off, usability, convenience, and security, because if you don't, so if you repeatedly interact with the protocol and it's always just the amount, and you have a lot more transactions. So I somewhat understand why they are doing it.
Yeah, I think, sorry, go ahead.
No, go
on. So just kind of thinking on it some, like, I mean, obviously like the operator would be like just a really easy way to delegate, basically any permissions, right? But if it were to be more configurable, I mean, you could kind of do something like the super app config word, right? Where you have like a couple of different options as to like what you can do. Like, for example, like I'd like to make an insured stream kind of thing where, like, basically if somebody's stream is about to close, then through this contract, I can close the stream for them. And if I don't, right, then we give them a payout, compensate them, that kind of thing. But right now you can only close a stream if it's insolvent, you're the sender or the receiver. And so like right now you just have to proxy it through a contract. It gets messy. It's a huge pain, but with operator permissions, just to close streams alone, then you could start closing these streams and insuring them like that. So I think either one would be really cool, but obviously like the operator is kind of just an easier choice for it. And a lot of people, like it was mentioned, like, I mean, I'm pretty sure like I've given Uniswap like infinite permission on my tokens. So I don't know. I don't see it as much of a difference there,
Actually, what we could also look into is taking the operator model and providing a few template hooks for the typical constraints you may want. Maybe that's also something which could work.
But if you think about the use cases, most of the cases we want, the most common case we want to target here is to allow a backend to close a stream.
Yeah.
So right, so we kind of limit the damage. So I think that's at least just for the sake of limiting the damages, minimize the damages that it could happen. I think granularity that level.
Because Tony said they need opening, so there it's already a bit different. And then the question becomes, okay, does it make sense to have a native parameter for limiting the flow rate or something?
Yeah, for the opening, may I interject? Sorry, for the opening, I would suggest not to use AC, but to use a meta transaction type of thing. So user sign a signature.
Yeah. Can we do that though?
Yes, we can. We already support, but I don't know if you have tried to integrate. So we whitelisted. So as a protocol, we have to whitelist what meta transaction forwarder we trust, and the one we trust currently is the Biconomy contract. So Biconomy contract is on-chain contract that does the signature parsing, and then then allow their backend to do the operation. So it's fairly secure, because that contract has limited feature. So we whitelist that contract. So you might want to check out that, because then you don't need the access control, because it's pretty hard to kind of design the right way of granularity of access control, right? So that would be alternative to use the signature instead.
Yeah, thank you for that. I didn't realize that actually was live. Yeah.
Oh. Yeah, so let me show you. So if you're not familiar with, I'm showing you the feature itself. How does it work in general? So we have the Superfluid host. So we have a batch call you might be familiar with, right? We have the forward batch call. So forward batch call would be the one that called by the contract we forwarder. It's a EIP 27771 forwarder, and it's implemented by GSN, the gas station network, and Biconomy. Biconomy has a dashboard. Let me just show you. Biconomy console. All right. I don't have the link. Anyway, they have a dashboard, and if I can have a login in this computer, perhaps not. Let me see. Or unfortunately, not on this computer.
I know a little bit about Biconomy. I've had a look at them before.
Right. So well, if you know batch call, basically it is the same thing, right? So you allow the Biconomy to just do batch call, but you're using the forward batch call function. They have similar. They have the exact same function signature apart from function name.
Perfect. I think that could work.
And if you implement it, you'll be actually the first one that try it out. So no one actually come to us. So if you have any integration questions, come to us. So I'm sure there will be some hiccups because no one actually did the implementation.
No, I appreciate it. One thing, in terms of scheduling. So what we'd want to do, I mean, the use case is we want to be able to schedule to open a stream, like a free trial. So you go at the end of the month, we're going to open that stream for you. Now, this scheduling system, this is sort of, we need to implement that backend ourselves, and then we submit the request to Biconomy.
Mm-hmm.
this is sort of, at least I'm thinking, I don't, maybe, I mean, it's a little off topic, but it's kind of by
Yeah,
common
I
this
think
feature
you
set.
could. I guess for you, the challenge is sort out the subsidy model, I guess. I mean, you usually need to pay for your economy cost, but you guys need to sort out somehow.
Yeah.
Yeah.
Okay.
All right, I went a bit off topic. Why not? I mean, we could have some support hours for the protocol forum in the end. Why not? Yeah, man, that's good. And we have 9 minutes left. Is there anything you want to add more to our original discussion about solvency buffer?
This 1/16 or 6.25% or the 15 minutes, however we want to slice and dice it. Could this be less or could this be bigger? Like, is there any reason, kind of like, where did this number come from? Just
Gut
yeah,
feeling.
just feeling. Okay, fair enough. Actually, it's not even important to get the number right in the first place. You can pick a number, then you can adjust based on how it works.
Do you
So-
have a gut feeling about what a good number would be?
I feel if you really want them to hurt the patricians and you really want the plebs to to have a feeling like they have skin in the game, I think 15 is a little too long. I feel like you want to.
I mean, don't
we
forget
do have
that
some objective. Yeah, sorry.
that it's the patricians having skin in the game. So
But
it
the
shouldn't be
pleb-
too short either.
Yeah,
The plebs want to make sure they have a chance, because what you don't want to feel if you're running a sentinel is, I'm never even getting an opportunity as a pirate or a pleb. The patricians are just gonna. The game is basically, it's so slow that the patricians can play this game whilst they're having a cup of tea.
Well, there was I mean, I don't know if like 15 is like a magic number per se, but I know like, so there's like one person who controls the pick on like every profitable token right now. But I think for a while, like something was up with their config or something, because they were liquidating all of them on a delay. And so like, because I mean, obviously it's not a 4-hour delay, so nobody was getting, any rewards for the liquidations, but whether it's like an issue in the config, or maybe it's like, network issues where it's like high gas costs, transactions are slow, things like that. Like there is still a chance, I guess. I mean, again, 15 minutes is, it kind of depends, but like there are plenty of times where like your sentinel goes offline or you have some issues like that. So I don't know.
I think we don't have to all just speak of the feeling, because we do have some existing data collected. I remember Nuno showed once. Nuno, do you have that data available? Like from the current liquidations, we have a kind of how do you say, this kind of power curve, in a way that most of the liquidation happens within 10 minutes of expected liquidation time. And so we do have the data. Unfortunately, if Nuno, you can show quickly, that would be fantastic. But otherwise, we do have objective data so that we can derive that information from just what happens since the token is rolled out. That could be instructive for figure out a number. But 15 minutes was originally the number we came up with. Yeah.
I can set it up. I don't have that information now.
All right. Yeah. We're building more data insights. So this is one of the data we do want to visualize, like solvency related data, right? So this is basic question that we should be able to answer, but we're still building it. So that by then, when we have it, we can answer the question quite easily. So how long it takes the sentinel to liquidate a stream, how much is the delay? And that's the number we want to optimize for, and as a kind of important metrics for the network healthiness in that sense also.
May I also ask, kind of, how are you thinking about development of the ACL and a new constant flow agreement? Is this sort of, so will there be a new constant flow agreement? Sort of what's the thinking kind of right now? Will it be extensions, sort of, yeah.
Yeah, it will be extension. So everything is maximizing the backward compatibility. So the way it could achieve backward compatibility is create a new type of data storage. So by default, it's 0. So it's backward compatible, right? And if there is data, meaning that some features enabled, then it will appear some values in that storage. So
Oh, they're upgradable, obviously. Silly question. Yeah.
So basically, when you check, is there a special permission? And then there'll be a new storage. Like Joshua is probably already starting to be familiar with the storage layout, right? So we're basically adding a new storage slot or something. And currently it's 0, meaning that there's no special permission. But when there is, then there'll be no number. So it should be possible to be backward compatible.
Good, really good.
Okay, I guess we can just end here.
Thank you, everyone. Have a good day.
Thank you very much. It's a good call. And we'll share the details later about the notes. Right.
Thanks, guys.
Bye, guys.
Thank you. Bye.